So this is the file of your Kruskal Wallis test. Let me write here, Kruskal Wallis test, and this is a type of your one-way ANOVA. You can say the alternate of your one-way ANOVA single factor. Right? You can see in this data, my file has 3 types of drugs: drug 1, drug 2, and drug 3, and collected data from the 20 respondents. Right? And the score has been given out of 10 in the form of ranks. Out of 10, because I give drug 1 to the few of the participants. I told you that this is what here groups are different, right? But data is same. Data set is same because we make 3 groups: a group 1 for drug for first drug, for drug second group there is another separate group for drug 2, and the separate group for drug 3. So here we found the 3 groups as we did in the air pollution file, Delhi, Ghaziabad, and Gurgaon, right? So in that file also the separate group was there. For the Delhi, the separate data has been collected for Delhi, right, as in this same file. So what you can apply here, you can apply Kruskal Wallis test, because this is a type of your one-way ANOVA. Go to analyze, non-parametric, all the non-parametric tests you will find in this one, right? Legency dialogues, go to legency dialogues, and apply this K independent sample, right? For the ANOVA we apply K independent and K related, but for the T test, right, in terms of non-parametric we apply this 2 independent and 2 related. For Mann-Whitney we apply 2 independent, correct. For the Wilcoxon we apply 2 related, right. For the Kruskal Wallis we apply K independent, and for the next we will apply the K related. Okay, so this time I will choose the K related, K independent sample T test, K independent sample. Now it is asking for test variable, so I will test pain score, right, and it is grouped by the drug type, right. So let me take this in the grouping variable, defining the range. Minimum is for 0. You can see in the variable view. In the variable view you can see the 0 is given to the drug 1, 1 is given to the drug 2, and 2 is given to the drug 3. So minimum is 0 and maximum is 3, right. Minimum is 0 and maximum is 3. Your Kruskal Wallis test take information like this. So go to analyze, non-parametric, legency dialog, and K independent sample. Select pain score as your test variable. Select drug test as your grouping. Define range. My range minimum is 0 and maximum is 2. I already tell you. All right, continue. Kruskal Wallis is already checked here. In the options you can opt descriptive if you want, and click on OK. Right now in this file you can see Kruskal Wallis that my mean rank is 14.60, 10.93, and 7.56 for each drug. This is the one thing, right. So the maximum mean is for drug 1, right. So this is the first thing you can say, that the I gave drug 1 to the respondents or to the patients, and they were more satisfied than drug 2 and then drug 3, right. So this is the one interpretation. Second is your based on the p value, right. P value is this is your p value 0.103, but this is greater than 0.05. So rejected. Your null is rejected because my p is greater than the, sorry, my null, I cannot reject the null, cannot reject the null. it is greater than the alpha, I cannot reject the null. And what could be null? That there is no statistically difference between group mean. There is no statistically difference between groups, right? But satisfaction level you can justify, because the mean is higher than the first mean is higher than the second mean, and second mean is also greater than the third mean. So you can reject your drug 3 for your analysis, right? You can say that there is no use to provide drug 3 to the patients. You can provide drug 1 and drug 2, right? Now the next test is a very important test, that is your Friedman ANOVA test.